Okay, yes. My name is Victor. So welcome back to the CCNA Switching, Routing, and Wireless Essentials course by Cisco. So like I told you earlier on, this is the level 2 training. So this course is offered by Cisco as a Cisco Academy partner. You could create an account on NetAcad to follow up with this training. Like I told you earlier on, the training has 16 modules. And if you want to follow this course and have access to the Cisco Learning Management System, you could send a mail or reply, and you're going to be given details on how to have access to this platform. So this is a instructor-led program. So as a Cisco Academy vendor, so we could give you access to the, give you a token. So you could purchase a token, have access just for $50, have access to the learning management system. So with that, you could receive further mentorship. You could take your exams. You could prepare for the industry exams. Once you're done, you get this badge. You get the CCNA Routing and Wireless Essentials badge. So this is the kind of badge you could get at the end of the day. Mine looks something like this. You could get a credit badge that you could attach to your LinkedIn platform and the rest. So you also get a transcript for your, so you could get, I just added some of the certifications on the credit platform. This is the Amazon Web Services Cloud Practitioner. This is IT Essentials. This is for Cyber Ops. This is for Essentials. This is for NSA, that is CCNA level 3, and it can be verified by an employer or just to show that you've actually gone through the curriculum, you've taken the exams, you've passed. So you could also inbox to get access to the platform. Okay, that's that. So back to the training. So we're going to be looking at the very first module, which is module 1. So module 1 is about basic device configuration. So we want to look at the entire 16 modules, and of course, all of the labs that are associated with all of these items to be able to help you better understand this CCNA level 2. Okay, so I'm going to expand this so that you could have a very clear view. So the course actually starts from here, right? So what are the basic objective of this particular module? Basic device configuration. So we want to understand, how do we configure our devices using security best practices? So there are some objectives for this curriculum, for this module. You want to understand initial settings for a Cisco switch. You want to understand switch ports to meet network requirements. Each network is not going to be created same. So each network would have its own requirements. So how do you do that? Then how do you ensure secure access to your switch? So you might be accessing your switch via a direct network cable. You can be accessing that through a remote access, or you can be using the USB method. So I'm going to explain each of all of those models, how you can do that, and as we ride on the course. Then how do you verify connectivity? If you've connected to your router, you're connected to your switch, how do you run some commands to ensure that you are actually connected? Now, boot sequence. Now, few things you need to understand how the Cisco switch operates. Step 1, just like your regular PC, if you check the channel, there's a complete recording for ITE, Cisco ITE. That is the introduction to, the Information Technology Essentials. There's a complete training on that on the channel. I think that is about 60 modules also. If you want to take the training, take the test, get certified and get the badge, you also make a comment in the comment section or inbox, or use the indication of interest link. Then Once you do that, we could give you access to the Cisco Learning Management platform. So on that curriculum, which is like the equivalent of CompTIA A+, right? Cisco ITE is equivalent to CompTIA A+. So that tells you how to fix systems, how to troubleshoot systems, how to do basic networking for systems. Though CompTIA is vendor neutral, that's to say that CompTIA does not train you on specific vendors, right? You train generally. That's how the curriculum is done. Whereas for Cisco, everything about the Cisco Academy, everything about the Cisco learnings are specific to just Cisco. There might be little mentions here or there, but you're being taught strictly on Cisco devices. So in your basic IT or CompTIA A+, there's what to call POST. So POST is power on self-test. So when you boot up any PC, boot up any machine, it does some series of tests to test itself, to check most of those startup components if they are all in shape. If they're not in shape, of course, they cannot throw up some error messages. They cannot tell you, maybe give some beep codes to tell you, oh, maybe the CPU is bad, or maybe the RAM is faulty, or maybe the keyboard is not connected or something. So the step one that the switch does is to run that post program, which is in the ROM, read-only memory. So it just checks the CPU subsystem, tests the CPU, tests the RAM, check the portion of the flash device that makes up the flash file system. Yes, the switch has like a chip that stores most of this information that you call the flash file system. Then next, it loads the bootloader software. Then the next thing it does is checks for low-level CPU initialization. Initialize the CPU register, which controls the physical memory that is mapped, the quantity of memory, and its speed. So it wants to check most of these things. That will tell how the switch is going to run. So once it initializes the flash file system on the system board, it now finally loads and loads the default iOS operating system. Now, in Apple devices, we normally say iOS. So it's small letter I, capital letter O, and capital letter S. But in Cisco, the operating system will say, for the switches and routers, we say iOS, capital iOS, right? Okay, now boot system commands. So once you boot up your switch, later on, once I'm done with most of the slides, I'm going to power up some of the physical switches we have in the offices, power them, show you the physical switch, show you the command line, and show you how to do some of these things. They're very straightforward. If you need to follow with me and you don't have a physical switch, either maybe a 2960 switch, or a 1841 router, or any of that in that range. Later on in this module, I'm going to be talking about the devices that you need, maybe if you want to practice these things at home, build your own lab, and the rest. So, or you could use the packet tracer. The packet tracer, it's complete, it's comprehensive. Exactly what you find in the packet tracer is what you're going to see if you have a physical switch, right? Just maybe some slight difference, but basically 80–90%, you're going to find exact same thing. So this the packet tracer, it's like a simulation environment for you to learn networking. So you have commands and the definitions. So the idea about chapter 1 or module 1 is for us to be able to understand some of these initial configuration. So the boot system, look at this config. So we call this the privilege mode on your switch if you followed up on CCNA1. So please, you could check the CCNA1 channel, or rather the playlist. And if you don't have knowledge about some of these basic configurations, so this is more like we're doing a recap before we now get into the CCNA level 2 curriculum. So this is what we call the privilege mode, right? So you have the execution mode where you can now run more commands that maybe it's have to do with configuration. So at the basic level, you could, okay, yes, I think this is the, what's it called? This is the execution mode because I'm already in config, right? So you say boot system. So what is boot system saying? That is the main command. That is the command that is anchoring all of these guys. Then flash the storage device because that is where the operating system on your switch lives, right? Then the file path to the system. Then this is the iOS file name. So like this switch we have in the office is a 2960 switch. Okay. Switch LED indicators. So there are some indicators that you need to be aware when you see a physical switch. When you switch it on, what does this first light shows? What does it mean? The RPS, what does it mean? The start, what does it mean? The duplex, what does it mean? The speed, what does it mean? The PoE, what does it mean? Power over internet. When I teach some of my students CCTV at times for IP cameras, you could use a regular switch or you could use the PoE switch, especially for a switch that has PoE enabled. So this very first one, if that light is on your switch, it then means that the system is receiving power and functioning properly. If a switch that has a second alternate power source, some of them is going to have one or two, then that indicator is going to be on. So for the port status LED, that is this third one, when it is green, it indicates that the port status mode is selected, which is the default. The port status can then be understood by the light associated with each port, right? Of course, for duplex, when green, indicate port duplex mode is selected. Then the speed, if this is green. So you see this stuff blinking. So this explains each of these lights and what they mean. Later on in the course, you're also going to learn how do you reset a switch. Let's say somebody gave you a switch or you bought a switch, maybe it's a used switch, or you came into as the IT analyst in your workplace, and you need to maybe start all over again. You don't mind losing most of those things or the backup configurations you have in your switch. If you need to set up the switch all afresh, how do you get to do that? So we're going to give you a step-by-step process on how to do that. To release that in a video in the channel. So this just shows you a table for each of those items. If it's off, what does it mean? If it's green, what does it mean? If it's blinking green, what does it mean? If it's amber, if it's blinking amber, then if it's alternating. So this is like your troubleshooting roadmap. When you see something and you don't understand what the issue might be. If you need to recover from a crash system, right? So how do you do that? Like I told you, I will release this in a separate video and maybe do that physically. How do you recover from a system that is crashed or a system you want to reset? So the steps are very simple. You connect a PC via console cable, right? So what is a console cable? How does a console cable look like? Right? Console cable. So console cable, at times we call a console cable a DB9 cable. So one end is DB9, 9 pins. Then the other end is your regular RJ45 port. So this RJ45 port goes into your switch. This part, you need an adapter, gets into your, this part goes into your switch. This part goes into your PC. But you need a USB adapter. Yes, that is it. This guy. So this is how you do it. This part goes into your switch. This part connects to this adapter. This part connects to the adapter, and this USB gets into your PC. That's the way to do it, right? So this is an image. This is what it looks like. Awesome. So this is the console port. You plug it in, you will see the console written behind the switch. This is actually a router, right? Same thing if it's a switch, if it's a router, you'll see the port written console. That cable goes in, then you get an adapter. So you call this a USB to serial adapter. So this DB9 is always called a serial port, right? So this is how you connect a switch or a router to your PC for configuration. So you can't just configure a router, a Cisco router, or a switch just that way. So the only way you could get into privilege mode to do configuration is one way is using a console port, right? Okay, so connect a PC by console cable to the switch port, configure terminal emulation software to connect to the switch, unplug the power cord, reconnect the power, wait for 15 seconds, press and hold down the mode button while the system LED is still flashing green. So this is the mode button, this guy here. So you connect, once it has loaded on your PC, you press this guy down for 15 seconds. Right? Continue pressing the mode button until the system LED turns briefly amber and solid green. Then you can now release that. What happens at that point is that you actually reset that switch, right? So of course, you could now maybe reinstall an operating system or recover your forgotten password or set up new password or do whatever you need to do. I'll release a special video or drop an outline, a guide, or release it in the blog on step-by-step on how to do that. But this is just the summary of how you can reset a crash system. So this is it, switch management access. So how do you do that? You connect your console cable to the switch. So in Cisco, anytime you see this guy, this symbol is a switch. Anytime you see this guy is a router. So to prepare a switch for remote management access, the switch must be configured with an IP address, right? The switch must be configured with an IP address. This is very similar to configuring the IP address information of host device. So later on in the modules, we learn how to give a switch an IP address, how to give a router an IP address. Okay, switch virtual interface, configuration example. So by default, the switch is configured to have its management control through VLAN 1. Yes. So if you start up a regular switch, all the ports, if it's a 8 port, if it's a 16 port, if it's a 24 port, if it's a 48 port, no matter the amount of port, by default, everything is going to be under VLAN 1. VLAN is called Virtual Local Area Network, VLAN. So that's to help you better manage your network. So if you create more VLANs, you can segment that switch. So everything is all in VLAN 1 by default. So for security purposes, consider the best practice to use a VLAN other than the VLAN for the management of VLAN. So because that VLAN 1 is a default VLAN, so you might need to create another channel, right, that you're going to now use to do your configuration, right? More on this later on. So if you have to do that, how do you do that? Simple. You connect the switch to the laptop via the scenario I've painted earlier on. Automatically this loads, this start blinking on your switch. You type in configure terminal or use a short form conft, C-O-N-F-T. That's a short form for the command. Once that happens, you get into interface VLAN 99. And the point is that you cannot just start using VLAN 99. You will first have to create VLAN 99. So in the course, you're going to learn how to create VLANs. I think that should be module. Just a moment. That should be module 3. So in module 3, we started how to create VLANs and how to do inter-VLAN routings, right? So let's take it step by step, one after the other. Okay, so you now give it an IP address, give it an IP version 6 address, say no shutdown. When you say no shutdown, you enable the management interface, you say end. If you don't run copy running config startup config, this does not save to the startup. It doesn't save. So you have to lose this particular configuration you have done if you don't run this last command. Okay. How do you configure a default gateway? Same thing. You get into the configure terminal, you set IP default gateway, give it this, and then you run it. You run this like a saving command. So how do you verify the configuration you have just done now? So on your Cisco switch, you just say show IP interface brief, and go to see the VLAN you created, the IP address you've assigned to it, whether it's down or whether it's up. Then if you say show IP version 6 interface brief, it's also going to give you all of those details. So this is how you can verify configurations that you've done. So there is a lab that you have that should be lab basic switch configuration. That should be lab. Is this a lab? Let me confirm just a moment. So the lab, you will complete the following activities: cable the network and verify the default switch configuration, configure basic network device settings, verify, manage. Okay, let me confirm if this is a packet tracer lab or this is a physical lab. Just a moment. Packet tracer. Okay. We'll see how to verify this later on. So, but later on, after the slides, the curriculum, we'll pick most of this lab and run them one after the other. Normally, the slides correspond. The labs here correspond to the about 31 labs you have here, right? So, but what this lab is about is just what we've mentioned. Then we're going to see how to run this on packet tracer. Then, of course, verify, test the connectivity, then manage the MAC address table. We did most of these things in CCNA1. I think that should be module, one of the modules. We talked about most of these configurations, how to run ping commands and see if the other item, the other end device at the other end is active, if it's up. Run some commands also to see what the MAC address table is, what the CAM table is. We also run ARP commands and the rest. So you could check up the CCNA1, you're going to see that, but I'm going to run these labs for the CCNA2 version. Then configure switch ports. So there's some things you want to understand when it comes to duplex communication. Back in the days, when you had less efficient switches were not so intelligent. So anytime you hear the word full duplex, you are saying that communication can be done both ways, right? That's the sum of it. Imagine if I can send information, I can receive information without collision, without issue. That switch is operating at full duplex mode. Most recent switches have that, but older switches don't have that. So that's why back in the days, if your switch runs for some time, what's going to happen is that they just get so much collision, so much information, so much packets of data moving around your network, packets of data looped around. And because the switch is not so intelligent in managing traffic, and because it cannot manage bandwidth efficiently, the switch just goes blank. So you now have error in connection. So you cannot no longer connect because it's just unidirectional. It needs you to just send information to the switch. Then once you're done with that, the switch can now start sending information back. So most of those switches were very, very low speed switches. But these days you have full duplex enabled in most regular switch you're going to buy in the market, and it's very, very 100% efficient because it can transmit and receive information at the same time, right? Okay. Anything here that is of importance? So the default setting for both duplex speed for switch port on Catalyst 2960 and 3560 is auto, right? So they could do whether it's 10 MB per second, 100 MB per second, 1000 MB per second, which is 1 gigabit per second. They will operate in either half or full duplex mode. They will give you full duplex communication, right? So there's what we call mismatch settings for the duplex mode, and the speed of switch ports can use connectivity, can cause connectivity issues, right? So imagine I'm sending data from a 10 MB per second port switch to a port that is 100 MB per second. That is a mismatch. You have traffic coming from a 2-lane road, then you have traffic coming from a 10-lane road. If you're coming from a 10-lane road into the 2-lane road, there's going to be issue. So you will not just get into the 2-lane road. There will have to be delays. There will have to be speed issues. And that's what we call your mismatch in speed. Same thing when you are planning a network, for instance, and you are going to be getting gigabit internet into your facility. But the devices that you run, that you want to use to share this internet facility to your end devices, to your routers and switches and whatever, the guy that is going to pick up the internet is a 100 MB per second speed device. So those ports, the ports are 100 MB per second. What's going to happen is that you're going to be getting gigabit speed internet, maybe fiber optics or point-to-point connection into your building. But at the end of the day, you will not have that gigabit speed internet distributed to your laptops and your phones and your printers and whatever. Why? The guy that is serving as the intermediary device between your source of internet and your end device is running 100 MB per second. So that is an inefficient way to plan and to manage your network. Okay, so this is just an explanation for the iOS command if you need to enable that. So configure terminal interface fast Ethernet 01. So that is the very first port. When we start doing the labs, you're going to understand this better because this is the very first port on this switch. So it's going to be 01, 02, 03, 04, 05 if it is 48 port switch up to the 48th port, right? So most of the times when you are doing configuration, you are doing configuration on each of the ports. For instance, your laptop has only one port. Yes, most laptops have one port. Most recent laptops these days doesn't even have an RJ45 Ethernet port. What they have is just wireless. So, but some devices, some laptops are going to have the port. So you just have one port. Your router, for instance, these days you now have routers that don't just have one port for connectivity, they have up to like 3 or 4. But your switches, for instance, your Cisco switches are going to have, let's say, 8, 16, 32, rather 24, 48, like that. So when you are doing configurations on that switch, you do configurations per port, per each of the ports, right? Anything you want to enable, if you want to put the port into VLAN or whatever, you do it per each of the ports. Okay, so this is still talking about the automatic medium dependent interface crossover. Now, you know, previously, when we make cables, let's say 15, 20 years ago, when we make Cat5, Cat6 cables, normally you are being told that when you want to use devices of same type, let's say laptop to laptop, when you are creating your Cat5 or Cat6 cable, you use a crossover cable, right? So you say you use a crossover cable to connect devices that are same type. Then you are being told that when you want to connect devices that are of different types, use straight through cables. So what do you mean by straight through cables? And let me see if I can get a diagram for you. Straight through, straight through, and crossover cables, right? But most of these things don't apply again, right? Why did I say they don't apply again? Because these devices are now more intelligent, right? They're more intelligent. So these are the scenarios where you can use a straight through cables. Scenarios where you can use crossover cable. See, all of these guys, same type, right? Switches. Well, this should be hub, router to server, PC to PC, right? So devices of same type, serving same type of function, use crossover cables. Devices of different form or different type. So a switch and a router, a switch and an end device, a switch and a server, a hub and a system, a PC, a hub and a server, right? Good. So back to our slide, we're talking about auto MDIX. Now the point is that newer Cisco switches, the MDIX auto interface conversion commands enables this feature. When using auto MDIX on an interface, the interface speed and duplex must be set on auto so that the feature operates correctly, right? So what we're primarily saying is that when you now use more recent switches and routers, it doesn't matter whether you're using straight through or whether you're using crossover cables, these guys will auto detect and understand that that guy at the other end is an end device, or that guy at the other end is an intermediary device, or whether they are same type, PC to PC or whatever, they will pick and they will communicate. But this used to be an issue when we used to do networking back in the days, where you have to make sure that you're asking yourself, am I connecting a PC to a router? I need to use a straight through cable. Am I connecting this to that? I need to use a crossover cables. So when automatic medium dependent interface crossover is enabled, the switch interface automatically detects the required cable connection type, straight through or crossover, and configures the connection appropriately, right? So that's just the thing you need to know about the auto MDIX. So these days it's not so much of a concern. So if you need to do some verification, what are some of the commands that you should be aware of, that you should learn, you should know? So you have the show interface. I'll talk about this later on. So you need to put the ID or the port number. So this is what it does. Show startup config. it displays the current configuration. Show running config, it displays the current running configuration, right? So if you're writing the exam, or if you're studying, if you need to practice most of these things, I implore you to take your notes, see how to get access to the Cisco Learning Management System. You take quiz, you take your exam, you get your digital badge, upgrade your skills, upgrade your knowledge, learn how these things work, and it's always fun. If you've not subscribed, make sure you subscribe to the channel so that once I release more modules, you are very much aware. And don't forget to share with your colleagues and friends interested in doing networking, because networking serves the foundation for either cloud computing, cybersecurity, and of course, other areas in tech. So this is it in action. Show running config. This is what you get. Same thing with this show interface, fast Ethernet 018. So this is the 18th port on that switch. So when you see S, it's normally switch. When you see R, is router. So that's how Cisco, the command line interface is. So same thing, show interface, fast Ethernet 018 to give you those details. Right? So these are some of the items that you have and their explanations, right? So what are input errors? What are CRC? What are frames? What are overruns? And what are collisions? So you have the explanations here. Input errors, right? Cyclic redundancy check. So is the check that the switch does so that it doesn't have errors before it passes information from one switch or from one device to the other. Then you have runs, you have guides, you have CRC, which I just talked about. Then you have output errors, you have collisions, and you have late collisions. So these are just the explanation for all of these error types you can have whenever you run some of these commands. So if there are things of concern, you want to check them out. Okay, troubleshooting network access layer issues. Don't forget, the OSI model is very critical. You need to understand the OSI model. I normally say, please do not take sweet potatoes alone. Yes, this morning I took sweet potatoes. Yes, I love sweet potatoes a lot. And my mnemonics for the, what's it called? For the OSI model. OSI model has to do with sweet potatoes. So if we are to, hope you can see this. Oh, this is not so clear enough. Let me just, okay, this is somebody's article on LinkedIn. Can this explains it well? I hope you can see this well enough. So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So this is the 7th layer. Most of us operate at this layer where we use our softwares, applications, and the rest. So the physical layer is where you have your hardware, that Ethernet port. Data link layer is where you have your switch. Network layer is where you have your router, so and so, like that. So we're trying to say, if you are to troubleshoot your network access layer, which typically is this guy, these 3 guys, physical, data link, network, and at times just these 2 guys is what you call your, network access layer, right? So invariably we are saying, if you have an issue and you need to fix it, don't start from the very top layer of your network. Start from your down below. You have a problem with your network, check out your hardware. Sorry, just even your cables. Because that's the very first layer. So in troubleshooting, you start from the lowest layer on your OSI model to troubleshoot your problems. Verify the proper cables At times, somebody might just have disconnected the cable and you're battling with your Chrome browser while you don't have internet. You're battling with your device manager while you don't have, while maybe your device driver is not installed. So always go from very top up. So that's what this diagram tends to explain. Secure remote access. So there's a protocol that is prone to phishing. Will I say phishing? Or rather sniffing. That's the word. So if you are going to be doing remote access to your switches or your routers, understand that protocols that are prone to sniffing, if somebody runs a tool like Wireshark, the person will be able to get to see your network credentials, your usernames, your password. They can be transmitted. Since Telnet, for instance, uses port 23, port 23 is a plain text protocol. So this is an assignment for you, for instance. You need to get familiar with most network protocols. Have like 10 to 20 upstairs in your head. Know what is port 80, what are the functions of port 80, what are the different type of tools and applications that use port 80, port 21, port 22, port 23, port 53. 53 is UDP, user ground data protocol. DNS uses that. Port 23, Telnet uses that. Port 22, second FTP uses that. Port 21, FTP uses that. 80 HTTP, 443 HTTPS. Understand most of these protocols and what they represent and what type of tools and application use them. The reason being that when you start running some of all these tools, if you see a port, you can tell what is active, what is on. You can also check the Cisco's Cyber Ops curriculum. It's a 29 module training series, is on the channel. Check that. You could go through the curriculum. There's a part that has to do with digital forensics. So if I did digital forensics, some of the thing you want to be doing is you want to be able to see what is happening as per background processes. So somebody might be running sniffing tools like Wireshark, for instance. So he'll be able to capture most of this plain text protocol. So you want to be careful about that, where you run this, how you run this, and if running remote access via Telnet is actually safe for you. Because you can see the password is CCNA, the username, I think, is admin, right? So SSH would be more appropriate. So SSH is 22, same thing with SFTP. You see, most of the password, if somebody running Wireshark is scanning your network by chance, it's not going to see plain text protocol, it's going to see gibberish. It's going to see them in ciphertext. Now, how do you know the version your switch is running on, right? When you get into the privilege mode, you just run show version. It's going to tell you the version. It's going to tell the release software and all of that. I think that's all. If you need to configure SSH, so this is the process you need to follow, right? You need to verify SSH support that the switch or the router supports that. Not all switches and routers support that. Then you need to have a domain. Then you need to generate RSA key pairs. Then you configure user authentications. Then you configure VTY lines. I'll talk about VTY lines later on. So VTY lines are just, you have from 0 to 15. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if you count 0, 1 to 15, so you have 16 in all. So in configuration, you could pick lines that you're going to use for your configuration. I'll look at this more in our curriculum, either in this CCNA2 or when I do the recordings for CCNA3. Okay. So this is just how you do that. So if you are going to configure your switch using a physical switch, if you can configure your switch physically, you need to use a tool like PuTTY. Let me see if I have PuTTY on this PC. Yes, I have PuTTY. So this is what PuTTY looks like. So PuTTY is just a tool you could use to do switch configurations, right? So this is it. So session, all you just need to do, if you're going to be connecting through that serial cable I talked to you about, you tap on this, go to your device manager. We'll do this later on. You will see how the switch is connected. When you set that cable, if you go to a device manager, it's going to tell you either COM5, COM6, COM7, COM whatever. So whatever you see there, the communication port is using to connect to your PC, you make sure you change it to this and you just tap on open. That's all. You have access to your switch. You can now have this. Rather, you have this interface, right? This shows up. You can now start typing. You can now start configuring. But if you want to configure through SSH, so you tap this. So you have to indicate the IP address. So you must have configured an IP address on the switch or the router like we talked about earlier on. Are we together? So PuTTY is a software you could use to do that. So everybody, please download PuTTY, have it installed on your PC. We'll look at it later on. So show IP SSH, so that gives you run all of this stuff. So there's a packet tracer lab that helps you do the following: secure password, encrypt communications, verify SSH implementations. So for all of the packet tracer labs, we're going to do that later on. So my focus now is to do the complete recording for the modules. You have firm understanding. Once we're done with that, we can start doing our labs. So we've talked about switches. Now it's for us to talk about a router. Very similar, slightly different. So for routers, you normally see R1, right? You could name your router anything. You could change this name to whatever you want to change it to. So before you could do configurations, you have to say conft, or you have to enter into your terminal, right? Then first thing you want to do, you want to give it a name. The name you want to call it R1. So the first thing that happens when you buy the router or you get a router, you're just going to see router hash. So you have to get into the configuration mode. It's just like in your PC, for you to do some kind of change up or stuff, whatever, you have to get into cPanel. You have to be an administrator. So that's how it is on the Cisco switch or router. You have to say configure terminal. Then you say hostname R1. So that hostname is the command, the primary command. R1 is the name you want to give to the router. So if you want to call it Southtech, you say hostname Southtech. Automatically, this name changes from router to Southtech. You cannot enable a secret class. So just want to say you want to give it a password, then line console 0, give it a password, right? Login, you exit. VTY 0 to 4. So remember I said it's from 0 to 15. So you are saying you want to configure this password stuff on line between 0 and 4. So you give it a password, you log in, you exit, service password encryption, and that is all. Right? If you want to do more configurations, we looked at this in CCNA level 1. But if you want to do more configurations, you can now say banner mode $ authorized access only. This is the message somebody is going to see when it tries to access the router. So this is just like a banner message. You could call this anything, right? So, but whatever you want to write should be within the $, right? It should be within the $. So you say banner mode T, you cannot write, welcome to Southtech Ventures. Please, you do not have access to this router, right? You could write all of that. So Once you're done with all of that, you say copy running config startup config. That's just the way to do that, right? You don't need to cram most of these commands. You use them from time to time. You get to them. You could have a note where you write all of these commands and what they mean so that you could have it as a reference point. So topology. So dual stack topology. So one distinguishing feature between switch and router is the type of interfaces supported by each. Maybe I give you this as an assignment. What's the difference between a hub, a switch, a router, an access point, a replicator? I'll come again. A hub, a switch, a router, an access point, an extender or a replicator. You could comment below. Now, for example, layer 2 switches support LANs. Therefore, they have multiple fast Ethernet or gigaport ports. The dual stack topology in the figure is used to demonstrate the configuration of router IP version 4 and IP version 6 interface, right? So this one just represents your dual stack topology. So configure router interfaces, just like we did on switches. So you get into the configuration mode, interface gigabit 000, that's the very first port. Give it an IP address, give it an IP version 6 address. You could give it a description, link to LAN 1, right? This is the command description. The name is link to LAN. So when somebody is trying to configure later on, the person can see what this particular port means. Imagine I have a 64 port switch. So, but you are saying that this particular port is the one that links me to the second LAN, LAN 2, or another network within the facility, right? So you go that way till you finish your configurations. Let me zoom this out. Okay, loopback interfaces, right? So another common configurations you want to do for routers is to enable a loopback interface. So a loopback interface is a logical interface that is internal to the router. Normally, for instance, for web developers, we say our loopback IP address is our IP address, the IP address of the system. Most of the times you hear of 127.0.0.1. So you are trying to say, when you configure it on a router, you're saying, what is my own fallback IP address, right? So you just need to say interface loopback number, IP address, you type in IP address and the subnet max. So there's a packet tracer lab that tells you how to configure IP for address and how to verify your connectivity. Same thing for IP version 6 address and also how to verify connectivity. So that will be done. So how do you verify you directly connected by the networks? So you can be doing interface verification commands. So basically, just like you do in your switches, you run show IP interface brief. So this is for IP version 4, whereas this is IP version 6. You know, for IP version 4 is our default type of IP address. So we just say show IP interface brief. But for version 6, we say show IP version 6 interface brief. So what does it do? It just displays summary of all the interfaces. So when we start doing our labs, if you run this command, you see what it looks like. Okay. So this is what it looks like. It shows you for this particular router. Now, when you add brief, it shows you only what is up, right? Or what has been configured. Most of the time, this router will have up to, let's say, 20, 30, 40, whatever other ports, but they were not configured, for instance, so it might not bring them up when you add brief. But if you just say show IP interface, of course, it will bring detail, it will bring everything, but the one that is up and the one that is down. Okay, output of the show IP version 6 interface brief. So This is just an explanation of the items what you see when you run the commands. Show IP route, that's what you see. What else? I think that's all. So this just explains most of the items that you have there. Then you also have a packet tracer lab on verifying connectivity. So I think that is all for the very first module in our Cisco switching, routing, wireless essentials, right? So if you don't have access to the Cisco Learning Management System, do an inbox or send an email. You're going to have access to that. You could take up your quizzes. You could take up the exam for the platform. You take your final exam and you have your Cisco badge. There's a packet tracer lab that tells you how to set up a small network, create the topology, verify connectivity. Most of these things we've addressed the different type of topologies in CCNA level 1. So what did we learn? After a switch is powered on, it goes through 5-step process from the power on self-test to the verification of the what's it called? The RAM, the processor. It checks the flash, if the operating system is there, loads that, does error correction, then it boots up and we can now further do correction. And for all of the lights you have on those indicators, they mean quite a lot. Okay. Are there new words that we've learned? Okay, I think this doesn't have it. So, like I said, you don't need to memorize all of the commands. Just get used to them. You could jot that down, and frequent usage, you get used to it. Thank you for watching this very first module. See you in the next module, and have a nice day.